Hi, Integrated Math 1. Welcome to lesson 5.1.2. So last time we finished off by constructing a square. Today we are going to construct a regular hexagon inscribed in a circle. Woo, but not till the end. Don't worry. We have some in-between steps before we get there. So don't panic. We're going to do a few things today, actually. Let's be honest. We're on page M5-25 in your workbook. And again, you're going to want to make sure you have a compass and a straight edge available to you today. We know that's how this works. So our goals today, we're going to use construction tools to duplicate an angle. Remember how we duplicated a segment? Now we're going to duplicate an angle. We're going to construct a regular hexagon inscribed in a circle using a couple different strategies as well. So this will be fun. Good times. So you've used construction tools to create a square. We didn't quite get to inscribing it in a circle, but we did create a square. And we are going to talk about how we can construct a regular hexagon inscribed inside of a circle. So to get us started on page 26, you can use your construction skills to duplicate a line segment inside a circle. We can duplicated line segments last time, right? We just used our little compass and we were like, it's this long. And then we made a little mark and we duplicated it. Hooray. So here you have circle A, and you can see I have a radius AB on my circle. I would like you to construct BC congruent to AB. So I want you to construct a congruent segment, same length as AB. We're going to call it BC, on circle A such that point C actually lies on the circle. Hit pause, see if you can figure this out, and then hit play when you're ready to check your work. All right, I'm going to show you what I did. So here I have my circle. Yay. Now, I want to make a congruent segment. So first of all, I'm going to be like, okay, my pointy guy goes on A. I'm going to adjust my pencil so that it matches B exactly. Awesome. Now, here's what I'm going to do. I'm going to take my point. Instead of making a starter line, I'm going to use the circle. I'm going to take my point here. I'm going to put it on B, and I'm going to make a little mark such that it hits my circle. We're going to call this point C. It does say we actually want to make a line segment, so I am going to use my straight edge to connect B to C, which I just did. Good job, me. Yay. So we just did part A. We constructed BC congruent to AB on circle A such that point C lies on the circle. Yay for us. Sweet. So it looks like this. Good job, us. All right. And I now would like you to connect points A and C. And then I want you to tell me, what do you know about the length of AC? Hit pause, write it down, hit play when you're ready to check your work. All right, I'm going to come back to my little guy here. They're just saying to connect points A and C. I can do that. I'll connect points A and C. Ooh. And it says, what do you know about the length? Oh, this is not my best connection. Pretend like I did here. I'm going to be fussy. I want it to be better. I'm going to go from C to A. Maybe that'll be better. Yeah, that's better. Cool. Not really. Now, what do I know about the length of AC? Well, I'll tell you what. I know that the length of AC is the same as the length of AB because they're both radii of the same circle, right? AB is a radius, AC is a radius. It's the same circle. So I know, I'm going to write that down here. So the length of AC is the same as the length of AB. I'll put a period on my sentence. Boom. Better. Sweet. So now I have a triangle, don't I? So the length of AC is equal to the radius of circle A. So I know AC is the same as AB. So let me ask you this question then. What type of triangle is triangle ABC? Hit pause, jot down your thoughts, hit play to keep the discussion going. So I know that AC and AB are the same length because they're both radii of the same circle. I know that BC is the same length as AB because we measured it and we made it that way. Guys, all three sides are equal. It's an equilateral triangle. Triangle ABC is an equilateral triangle because both AB and B and AC are radii and BC is congruent to AB. All three side lengths are equal. Yay. So here's the real trick question. What do you know about the angle measures of a triangle ABC? What do you know about all those angles? Hit pause, jot down some quick thoughts, hit play when you're ready to check your work. Well, I'll tell you what I do know, guys. I know that three congruent sides means three congruent angles. I also know a few other things. I know that all the angles in a triangle add up to, hang on, I got my pen, there we go. I know all the angles in a triangle add up to 180. So angle A plus angle B plus angle C should add up to 180. But I also know that they're all the exact same, right? Three congruent sides means I have three congruent angles. So x plus x plus x should equal 180 degrees. So that's 3x equals 180. And of course, if you use a calculator, 180 divided by 3, that's 60 degrees. Oh! So the angle measures of triangle ABC are each 60 degrees. 60, 60, 60. Yay! Awesome. So we're just kind of setting the stage here. We're kind of setting the stage for that hexagon. So we're going to come back to that circle a little later, okay? So don't toss it. We're going to come back to it. Let's come back to the angles. We said that angle was 60 degrees. I want to come back to that for a moment. Not only can you copy a line segment using construction, you can also copy an angle using construction, right? Using your straight edge and your compass. You can use these to copy angles as well. Do you know that? So as we've done before, I'll show you how this works here, and then I'll show you how it works on a piece of paper. So to first of all, we're given an angle. Hooray! Here's my angle. Awesome job. I need to construct a starter line. So we're going to use a straight edge to construct a starter line. We'll call it point C, and we'll say that's our new vertex. We're then going to go back to the original angle, and we'll construct an arc with a center at A, and we'll use that same radius to construct a new arc from center C. We can label these points B and D. And the deal is you're then going to adjust your compass to measure that distance from B to D. So construct an arc with the radius of length BD and center E. Yeah, so we're going to measure this. I know this is confusing. Once you see me do it, though, you realize it's not so bad. So we're going to measure this, and then we're going to use that to make a little notch right there. And then, boom, that's where the other side of your angle should go through. Construct ray CF. Such an angle BAD is congruent to angle FCE. Now, this was a little confusing, right? There's a couple more steps going on here. So I'm going to show you real quick. I have it here. I'm going to duplicate this angle. All right? I'm going to duplicate this angle. So I'm going to start. So this is the OG. This is the original. I'm going to start by making a starter line. I'm going to make a starter line. And I'm going to make my vertex. I'm going to call it C because why not? I can. And here's what we're going to do. I need to make an arc here. So I'm going to take my pencil, and I don't care how big it is. You probably don't want it to be too big. But my pointy guy is going to go on A, and I'm just going to make a mark an arc such that it touches both sides. Don't let it slide. Come over here to C, and again, make a matching arc. Great. Now you can see this creates two new points for me, doesn't it? They call these points B and D. You can call them whatever you'd like. Now I'm going to use my compass to measure that width, right? I'm basically measuring how open my arc is, right? How open my angle is. So I'll put a pointy guy here. I'm going to adjust my pencil such that it hits B. This is just like when we did the line segment and I was like, where does it hit? And we're like, it hits right there. And I adjusted it. Don't let it slide. I'm going to come over here. I'm going to put it here, pointy guy on that side, and then I'm going to just make a little arc, make a little notch. So I just measured and I did a matching one up here. And again, you can call these whatever you like. I believe the book is calling these E and F. You can call them whatever you like. But now I know, here's one side of my angle, and now I know the other side of my angle, I'm going to use my straight edge, should come right through here. Not my best, but get the idea. And look at that. I just copied the angle. So this angle measurement should be the same as this angle measurement. It's not perfect, but it should be pretty close. I should have done a pretty good job of it, kept it pretty exact. The problem I always have is if my compass slides. It drives me crazy. So I would like you to try this. You have down at the bottom of page 27, M5-27, you have angle B. Don't worry about verifying it with patty paper. I just want you to duplicate angle B. Go ahead, hit pause, see what you can do with this, and then hit play when you're ready to check your work. All right, you ready to see how you did? I'm gonna come over here. Boom. So here's my angle B, same as yours. So step number one, I need to do an arc that hits both sides. It doesn't have to be a big arc. You can make it as big or as little as you like. I don't want it to be very big. I'm just gonna make sure it hits both sides. Woo! Oh, and you know what I forgot to do first? I didn't make my starter side. I need to make a starter line. I'm gonna make my starter line. That's slack on my part. I'm gonna say there's my new vertex. I'm gonna call it B prime. All right, so I made my arc here, right? I made my arc here such that it hit both sides. It got a little wobbly. In fact, I'm going to redo that. It got wobbly. If it gets wobbly, that's when things go off. So I want to be careful about that. So I'm going to make an arc. My point is on my vertex B, and I'm just going to make an arc such that it hits both sides. Totally drop my straight edge. I'll need that in a minute. Don't let it slide. You're going to do a matching arc over here, right? Oh. Helps if I put the pointy guy on my vertex, pointy guy on B. And I'm going to do a matching arc over here, a nice big one. This one does have to be kind of long because I can see it's an obtuse angle. Oh, it's kind of a big angle. There we go. All right, starter line, matching arcs. Now I'm going to measure, right? I'm going to be like, okay, pointy guy here, adjust my pencil over here. And sometimes it helps to actually make the points, to be like point. Sometimes that just helps. So I'm going to use my compass to measure now, right? I'm going to put the pointy guy here. I'm going to adjust my pencil such that it goes right through there. Ooh, whoa, too far. Like that. And then I'm going to do a matching mark over here. Don't let it slide. I'm going to be like, oh, this is not my best ever, but you get the idea. And there's my other point. This isn't a very good one. I didn't do a very good job. Sorry. And there's the other side of my angle. Wow, I'm not doing a good job. I'm sorry, guys. This is not my best ever. But there we go. Yeah, matchy. Sweet. I hope you did all right with this, because now it's time for the next challenge. Here I have angle A. I want you to construct an angle that is twice the measure of angle A. And you may have to give a little bit of explanation there too on how you did it. Go ahead, this is the challenge. Hit pause, see what you can do with this, and then hit play when you're ready to check your work. All right, you ready? I'm gonna come over to my camera here. It doesn't have to be the same orientation as this, so just to make my life a little easier, no, I'll do it similar. I could make a flat starter line, that would be okay too, but I'm gonna go ahead and make a slanty starter line. And I'm gonna be like, that's point A prime. So my new vertex. So make my starter side, and then Remember, we make an arc that hits both sides, right? Now, this is about to be double. So I need to make sure, don't let it slide, but I'm going to need to make this arc a little bit longer than the other one, because we know we're doubling the measure of this angle. So I did need to make it a little longer. Again, pointy guy here. So I'm going to use this as a measuring tool now, right? I'm going to adjust, just that my pencil hits right on the other side, right there. Cool. And now I'm going to do that over here, put my pointy guy here, make a mark. But remember, we're doubling it. So I need to do this twice. Hop and twice. I needed to do it twice. Oh my gosh. So now it's got to come through over here. Over here. And I'm going to just use my ruler, straight edge, boom. And I just made an angle that's twice the measure of this angle. Oh, what? Look at that. So I did my measurements and then I did it boom, boom, twice to get all the way across, double that angle. Mine is a little more slanted. Theirs, they certainly did it a little more, they did it flat on the one side and then out. Either way is fine. It all works. It all works. So let's come back to that circle in the getting started activity, right? In the getting started, we created an equilateral triangle by duplicating the length of the radius to create a chord. And you can construct additional chords to inscribe a hexagon. We can just keep doing what we did over and over again. That trick that we did at the very beginning where we just measured the length and we were like, put it on the circle. You could keep doing that to create a hexagon. So you can use what you know about copying a line segment to construct a regular hexagon inscribed in a circle, just as shown using a compass and a straight edge. So if you're looking on page M5-29, we did skip a little bit here. That's okay. We are going to use circle A to complete our construction, okay? So start by doing what we did before. So you're going to want to copy the radius of circle A. So start what we did doing before. Just start. Can you just draw in a radius and then draw on the chord just like we did in the getting started activity? Can you just start with that? Go ahead, hit pause, work it out, hit play when you're ready to check your work. So just like in the getting started activity, I'm going to make my radius. You can call this B. You can call this whatever you like. I don't really care. We'll call it B for now. And just like in the getting started activity, I'm going to copy it. Put my pointy guy here. Make a little mark. And I think we called that C, right? Now don't lose this length on Y. You have made a chord. That's just a line segment with its ends on the circle. Can you keep doing that? Can you create, and I'm going to bring up the directions here, you can see better. Can you create 6 of those chords around the circumference of the circle A such that they're all congruent to the radius and their endpoints are all equidistant from each other? Can you keep creating those chords? We did B, we did C. Can you keep creating those chords around your circle? Hit pause, go all the way around the circle, connect them up, and then hit play when you're ready to check your work. So I still have my compass at the measure it was before, right? I still have my compass at that AB length, and we used it to create C. I'm just going to keep going around the circle. I'm going to put my point on C. I'm going to create another notch, and I'm just going to keep going. I'm going to create another notch. I'm going to create another notch. I'm going to create, I don't know if you can see, sorry, I keep going off camera. I'm going to create another spot. And if I do this one more time, it should put me right back at B, which it does. Good. And we want to connect these consecutive endpoints. So I've just made a whole bunch of radii and a whole bunch of chords. So we can call that C. That's what B, C. What do you want to call that? D, E, F, G. I'm just going to give it all the names. Why not? And we're just going to connect these. Connect E to F. I'm going a little bit off. Sorry. Oh no. Connect F to G. Sorry, I'm trying not to go off. I'm not doing the best job ever. And then I'm going to connect G back to B. Oh, look at that. You just constructed a regular hexagon. Look how perfect it is. Ooh. I mean, if you wanted to go really pretty, you could draw in all the radii as well. You could just like go all kinds of crazy with this. You could be like, I'm going to go from here to here. You could go as crazy with this as you like. I mean, that's fine. Make it all pretty and all the bits and all of that. Ooh. Sorry, some of mine are going crooked despite the straight edge. I'm just having too much fun, I guess. Okay, there we go. Oh my gosh, it's the most perfect little hexagon ever. So magical. Look at that. Ooh. So yeah, you just created a hexagon inscribed in a circle. Good job. Well done. Well done. As always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, come talk to me, and I'll see you guys soon. Bye.